Hello, my name is Fitsum. I'm a Morgan State University student.
And my name is Alberto Espinoza. I'm an undergraduate student at University of Illinois at Chicago.
For this summer, we were working on the project called MUD, which stands for Manufacturer User Description, under the advisement of Dr. Kevin Carnegie and our mentor, Edmund.
Okay, so these are the topics that we will be discussing today, and our focus is on Internet of Things security. So, our goal is to be able to reduce the threat surface of an IoT device. An IoT device can range from being a smart LED light bulb to a bit more complex Google Home. These can also be security cameras and smart fridges. These devices don't come with pre-installed high-level security software because these devices are unique. IoT devices have several things in common. They have constrained communications, they are meant to have a single purpose, then they're very easy to use and require as little configuration from the user. Because of this, IoT devices becomes with vulnerabilities, and hackers use these to launch attacks, which I will discuss shortly. To give you guys a global perspective, this graph shows that IoT devices are increasing dramatically. These numbers are in the billions. This graph illustrates that IoT devices are adapting even more to our daily lives. So, as I mentioned before, IoT devices have vulnerabilities and hackers use them to launch many attacks. Even if the user thinks that they are safe because they didn't put any of their information into the device, they are wrong because they're still vulnerable for an attack. Hackers can see the contents of your flash. They can see the video recordings that your security camera or baby monitor has taken. They can see the search history in your Google Home and sell this information to advertisers. Hackers can rewrite persistent memory content, and they can also make your IoT be a part of a botnet. This means that they are able to compromise your device and have full control over it. The users will not know because their device will still function as normally. So these devices turn into zombie computers and use them to launch DDoS attacks to shut down servers. DDoS means distributed denial of service. So depending on the server the hackers are trying to shut down, these hackers require about 10 to hundreds and thousands of these devices. So taking down servers not only requires several hours to repair, but servers will lose money from the services they cannot provide during that time. So to give a quick illustration, this graph shows that devices are not able to protect themselves over time. Devices rely on system updates. For example, looking at this orange line, mobile phones' ability to protect itself increases when they get system updates because the update has a purpose to patch vulnerabilities and protect it. However, on average, IoT devices have a life cycle of a year. This is because manufacturers have stopped supporting them or they have gone out of business. Now, hackers can run many simulations to find these vulnerabilities, and trust me, they will find them. A promising solution is given by Cisco. Cisco is proposing and working on a standard called MUD that will work on switch or routers to protect these devices. So instead of having security embedded into the devices, the switch will be in charge of protecting any device that connects to it. So the standard is MUD, and it stands for Manufacturer Uses Description. So whenever a manufacturer creates an IoT device, they are required to create a MUD file for that device. A MUD file is written in JSON format and shows everything that the device should do and nothing more. This includes specific port numbers, protocols, website, or other controllers that the device needs to talk to. The switch will implement an access control list based on these specifications to govern the behavior of that IoT device. So in our research, we divided our work into three phases. The first is working with the Cisco MUD Manager, the second is on the IoT, and the third is on the Cisco switch. My partner will now talk about phase one.
During phase one, we were tasked with two objectives or two tasks. The first task is to pick an operating system that is compatible with our Raspberry Pi and be able to work with MUD, meaning manufacturer user description that is written by Cisco. And the second task is to configure this MUD on our Raspberry Pi. So when it comes to picking up an operating system, we looked at a lot of Linux distribution operating systems, and we picked the one that is called Ubuntu Mate. We picked Ubuntu Mate because one, it has the same feel as Windows. Two, it doesn't take that much of space, and it doesn't require that much of processing. horsepower from our Raspberry Pi. So we picked Ubuntu Mate. Once we picked Ubuntu Mate, the next step is to install Mud Manager on our Raspberry Pi. To do this, we have to first set up a foundation for Mud to come in and work properly. Meaning we have to put all the dependency files or all the dependency programs on our Raspberry Pi so that Mud can work perfectly. So this dependency files range from OpenSSL, CJSON, Mongo database, and libcurl, and some other many more that I didn't mention, which help or assist Mud in performing the right way. Now at this stage, we have already installed our Mud Manager, meaning we with the dependencies and Mud being installed already in our Raspberry Pi. And the next stage is to test and to see if the configuration or the installation that we just have performed is correct and working well. To do this, with the help of Cisco, meaning Cisco has already created a test file in their Mud Manager, so that anybody who tries to deploy this on their on their switch or on their router can run this program. So this is called the file is called Luminaire that test if your Mud Manager is working or not. To do this, first you have to start your HTTP server, your RESTful server, and then your Radiant server. We were able to start all the servers and they were able to execute correctly, and we were able to get all of the outcomes that Cisco stated you should get if your Mud Manager is working perfectly. Since we have already successfully installed our Mud Manager on our Raspberry Pi and successfully completed the testing process, the next stage is gonna be to go to phase 2, which my partner is gonna talk about.
So now that our Mud Manager is up and running, our next step is to run this program on an IoT device that we create. So if it works for our IoT device, it will work for the second device and a third and so on. So we built a simple email and moisture sender. This is implemented in a headless Raspberry Pi Zero written in Python. It has 3 basic functionalities. It checks the moisture level, it will get the current temperature from weather.com, and it will email this information to the user. It was important to have these functions because we wanted our device to have several internet services. So since this is a headless Pi Zero, our device was not connected to a monitor. We had to enable SSH, which means secure socket shell, to wirelessly connect to it through our laptop nearby, so we can have control over the Raspberry Pi's terminal. So with this, we started our simple mail transport protocol on port 587. This is a public accessible domain and service that Gmail offers. So after that, to get the temperature, we learned to do HTML scraping. As you guys can see, we open up the browser to weather.com and open up its HTML file. From there, we had to find where the temperature was located, and it took us about 3 lines of code to get this information. Now that our IoT device is built, we had to create a MUD file for it. As you guys can see on the left, this is written in JSON format and it demonstrates the access control list for our IoT device. In order to locate this file, we need a specific URL, as you guys can see in the top 3rd line. This file is located at gmm.com/moisture. So we did not create a public domain. We used Apache server to provide us means for a localhost. We used self-signed certificates to host this website for us. As you guys can see on the right, this is a screenshot of our website that contains several MUD files. We did this because in reality, when a user has an IoT device at home, the IoT device will emit a URL to the manufacturer's server, and that server will be miles and miles away from home. So we simulated this in Apache to hold our MUD file in the web. Now, after successfully completing our IoT device and server, my partner will now talk about the next phase.
This architecture that you're seeing on your screen is to give you a bird's-eye perspective of what our project does and how many phases we have already completed. As you can see that we have already completed phase 1, which is configuring and installing Mud Manager on our Raspberry Pi. And phase 2, as my partner explained, we were able to create our own IoT device and configure it and setting it up. The next phase is going to be phase 3, which was a big challenge for us, which is setting up and programming and setting up a switch, which was the biggest challenge that we faced. And This is what I'm going to talk about. So during phase 2, we dealt with switches, but let me just give you a quick overview about switches. Switches are devices that helps you connect multiple devices on one network and allow information flow between between those devices, which makes it a very ideal device in our case. Meaning, we want our mud manager to talk to our IoT device and IoT device to our mud manager, and we want both of them to be on the same network. So switches are very important and it's very ideal. Once we understood that switch does that, we needed to know what kind of switch can we pick, manageable or unmanageable. Manageable switches are the ones that you can program, and unmanageable switches are those you cannot program, which are just plug and play. So for this project, we went ahead and picked a manageable switch, meaning where we can put our own protocols on it. So what did we put on our switch that made us choose a manageable switch is that, one, we made our switch a DHCP server, and we made our switch a Radeon client. So what those means is a DHCP server is a program that helps you assign IP addresses to a device that is trying to go online. So if you have your phone try to go to your wireless network, a DHCP server is going to assign an IP, and now your phone can go online. So this is a very important property that we needed. And the next stage is the RESTful server, which is responsible for authentication, verification, and accounting for every transaction between our IoT device and the MER manager and the server. So those things has to be settled first. So since all these moving parts were involved with the switch, we were having a lot of challenges. So the challenges that we were facing were first the port communication between one of the servers and our clients, or there was a problem with signature. So the first problem, as I said, there was a port conflict between our starting our HTTP server and our Apache server. What happened was both of our switches were listening on the same port, resulting that whenever we asked our HTTP server to start, it says the port has already been used, so I cannot be started. So this problem persisted for more than a day or two, and we didn't understand what was going on. And then after several readings and mentor helps, we were able to understand that they were listening on the same port, and we need to separate those ports. And the other biggest problem we were having besides port problem is certification, meaning we had two phases. One, certification for our web server, and the other one is certifications for our file. So what happened was we signed our files with a different certificate, and our web server with a different certificate. So resulting in conflict of verification. So we were able to overcome this problem by making sure that all of our certificates were signed by the same author. And we were able to overcome this and completely solve our problem. So to give you a quick summary of what we did until now is we have created our own IoT device, configure our switch to be a DHCP server and a DHCP server and a Radeon client, and deployed MUD on a Raspberry Pi, and we were able to do this until now. So once we have already put these things together, we tested it, and the results, my partner is going to talk about all the results that we got.
Now that my partner has gone through technical process of MUD Manager, we run this program with our IoT device and got this output. This is similar output as we showed earlier with Luminaire example. So this output demonstrates that we were successful on retrieving the MUD file from the Apache server, and we're able to extract the access control list. Now, our Cisco switch can understand the access list that it will need to implement on itself. As you guys can see in the bottom 3 lines, this is the language that Cisco switch can understand perfectly. To have the switch receive this output, MUD Manager needs this specific URL that is shown in the top second line, gmm.com/moisture. So as we mentioned, whenever an IoT device tries to connect to a network, this device starts the DHCP protocol, which means Dynamic Host Configuration Protocol. This IoT wants to retrieve an IP, as you guys can see at the bottom. we use Wireshark, a software, to see all the traffic in our switch. And doing the DHCP transaction, we see that our IoT starts off at an IP address of 0.0.0.0, and it's contacting the DHCP server. Then on the second line, our switch gives it an IP address of 2.11. At the very bottom, we investigated the packets of our IoT was sending, and it clearly shows the URL. This proves that the switch can now distribute IP addresses and retrieve URL from the MUD manager to work properly. So in conclusion, IoT have vulnerabilities, and they come with minimal to no security programs pre-installed. So these devices rely on system updates that are not guaranteed over its lifetime of an IoT device. So Cisco is proposing and working on a standard for all switches to work with, which is called MUD. With this, these switches will be able to enforce access control lists specific to any and every device that connects to it. So for our future work, we want to work with MUD-G and MUD-DI, which are extensions to Cisco's MUD manager. These extensions will help us create and verify MUD files that we will create for devices that do not have MUD files associated with them. Because in reality, not all IoT devices in the world have MUD files. We also want to work with scalability. As of right now, this implementation of MUD works with Cisco switches, and we want to make it work with other regular switches and routers, because in reality, everyone will not have this massive, expensive switch at home. Finally, we want to make this process autonomous. So this process can work in the background, and whenever an IoT tries to connect to the network, this whole process will start and the switch will implement an access control list by itself. This concludes our research here at Morgan State University. I hope you learned a little about the importance of Internet of Things security. We now present to you a demonstration video.